Scientists finally discovered a new way to travel faster than light. Traveling faster than the speed of light has always been viewed as a fantasy, reserved for characters in sci-fi television series. Yet, a flurry of recent findings on the nature of space and time suggests that there might be a way to break Einstein's supposedly inviolable speed limit after all. According to one of the world's top scientist, spaceships that travel faster than warp speed are possible. It may sound like science fiction, but it is all possible. Does this mean that Einstein was wrong after all? Well, find out in the video. So, are you excited to know more about it? Then switch this video to full screen and watch this video till the end. Hello everyone. Welcome back to the Tech Universe. Before starting, don't forget to hit the like button and subscribe to our channel to get more updates on the space and tech world. That being said, let's begin. So, as part of a recent study, physicist Dr. Eric Lentz proposed a way by which a rocket could theoretically travel faster than light, over 186,000 miles per second. If astronauts were to travel at that speed, they would be able to reach other star systems in just a few years, allowing humanity to attempt colonization of faraway planets. A rocket using current rocket technology would have to travel approximately 6,300 years in order to reach the nearest star to our Sun, Proxima Centauri. In the past, so-called warp drives have been proposed, but often they rely on theoretical systems for which the physical laws can't be broken. And this is because Einstein's general theory of relativity holds that nothing can travel faster than the speed of light, because to him nothing is physically possible to travel faster than that. Scientist Dr. Lentz, a professor at Göttingen University in Germany, says that his imaginary warp drive would still operate within the limits of physics, as opposed to other theories that rely on exotic concepts, such as negative energy. He uses a new theoretical particle to get around this issue. According to a press release from Göttingen University, these superfast solitons can travel at any speed while obeying the laws of physics. A soliton is also referred to as a warp bubble, is a compact wave that acts like a particle while maintaining its shape and moving at constant velocity. According to Dr. Lentz, his theory came about after analyzing existing research and discovering a number of gaps in previous warp drive studies. It is his belief that solitons can travel faster than light and create a conducting plasma, as well as classical electromagnetic fields. Both of these concepts are understood by conventional physics and obey Einstein's theory of relativity as an explanation. While this invention has the tantalizing potential of enabling faster-than-light travel, it is still very much in the concept stage for the time being. And due to the nature of the contraption, it would require an enormous quantity of energy, which would be beyond the capabilities of modern technology. And for the amount of energy that would be saved, Dr. Lentz believes it would have to be drastic, with energy savings of approximately 30 orders of magnitude to be in the range of modern nuclear fission reactors. He said, fortunately, several energy-saving mechanisms have been proposed in earlier research that can potentially lower the energy required by nearly 60 orders of magnitude. It is expected that the astrophysicist will now put more effort into developing a workable version of the technology. The research done by Dr. Lentz and his peers has moved the topic of faster-than-light travel away from theoretical research in fundamental physics and closer to engineering. According to him, the next step is to figure out how to bring down the astronomical amount of energy needed to within the range of today's technologies, such as a large modern nuclear fission power plant. Then we can talk about building the first prototypes. As explained by Lentz, his use of classical and quantum fields can be seen in classical and quantum gravity, where fellow researchers Alexei Bobrik and Jaini Mardar have written a paper on the subject that has been accepted for publication. This paper proposes a general model for a warp drive that incorporates all existing positive and negative energy warp drive schemes, except for Lentz's, noting that this likely forms a new class of warp drive spacetimes. It is, however, argued that a Lentz-type warp drive is no different than any other type of warp drive in the sense that, at its core, it is a shell of regular material and is therefore limited by Einstein's cosmic speed limit, concluding that there is none known way of increasing the speed of a warp drive beyond that of light. Although Lentz realizes that there are huge hurdles to building a warp drive, he believes that these hurdles are not insurmountable. He stated, "This work has moved the problem of faster-than-light travel one step away from theoretical research in fundamental physics and closer to engineering." As soon as Lentz has addressed the question of energy needs, he will develop a means of creating and accelerating, and dissipating and decelerating the positive energy solitons from their constituent matter sources. then prove the existence of small and slow solitons in a laboratory, and finally address the horizon issue. In his words, this will be necessary if we are to pass the speed of light with a fully autonomous soliton. However, as mentioned before, the idea of creating warp bubbles is not a new one. It was invented in 1994 by the Mexican physicist Miguel Alcubierre, who named them warp drives in homage to the sci-fi series Star Trek. Nevertheless, it was thought until Lenzi's work that the only ways to create a warp drive were through the use of vast amounts of negative energy, or by manipulating dark energy, which would presumably require some sort of undiscovered matter or exotic substance. In order to solve this problem, Lenz used a geometric structure of space-time unexplored at the time in order to derive a new family of solutions to Einstein's general relativity equations called positive energy solitons, in spite of the fact that Lenz's solitons appear to conform to Einstein's general theory of relativity and eliminate the need for creating negative energy space agencies, are very unlikely to begin building warp drives anytime soon, if at all. The reason for this is partly due to the fact that Lenz's positive energy warp drive requires a tremendous amount of energy to operate. It is estimated that to power a 100-meter radius spacecraft, you would need the energy equivalent to hundreds of times the mass of Jupiter, according to Lenz. He states that to be more practical, it would be necessary to reduce this requirement by about 30 orders of magnitude to be on the same level as a modern nuclear fission reactor. In the current context, Lenz is looking into existing energy-saving schemes to determine whether the amount of energy required can be reduced to a practical level. Additionally, any warp drive would also have to overcome several other serious problems. In fact, Alcubierre views Lenz's work as a significant development and cites the horizon problem as one of the most pernicious in his work. He explains, a warp bubble traveling faster than light cannot be created from inside the bubble, as the leading edge of the bubble would be beyond the reach of a spaceship sitting at its center. The problem is that you need the energy to deform space all the way to the very edge of the bubble, and the ship simply can't put it there. However, it should be noted that warp drives can alter the region of flat spacetime in which they are installed. It can, in particular, speed up or slow down a clock inside the drive. Think about what it would mean if there were such a thing available to us. Would you like to put someone with a terminal illness on ice? How about sticking them in a warp drive and slowing down their clock? In their perspective, a few years will pass, but 100 years will pass on Earth. Not nearly enough time to find a cure. Do you want to grow your crops overnight? All you have to do is put them in a warp drive and speed up the clock. For you, it will take a few days, while for your seedlings, it will take a few weeks. Moreover, there are even more exotic possibilities. By rotating the spacetime inside a drive, one may be able to build a battery that has the ability to hold immense amounts of energy. It is still far from reality to travel faster than the speed of light. Even so, warp technology would be a revolutionary step forward on its own. Anyway, what do you guys think about this? Tell us in the comments. And that's it for the day, guys. We'll see you in the next one. Until then, stay safe, peace.